exactly 20 years ago, when Microsoft was trying to build a Google competitor search engine. And so one of the strategies that we took up on was, we will actually build state-of-the-art machine learning algorithms to solve the problem of search quality, like being able to give best possible search results. Now, in this experiment, what was done is there was a bunch of X-rays where the model was very accurate and it was classifying to be cancerous and non-cancerous. But then when you looked at a particular set of examples, why the model was classifying, it pointed out to a certain part of the X-ray that is contributing to the cancerous nature of it. So this is basically a radiologist marking which were cancerous and which are not cancerous. And this is basically classic data leakage where the model was picking on signal that it shouldn't be.
Hello and welcome everyone to the next episode of the AIM Media House podcast Simulated Reality. Today we have with us the founder and CEO of Fiddler AI, Krishna Gade. Welcome Krishna, how are you doing today?
Yeah, great to be here, Kashyap. Thank you so much for taking time. I'm glad that we're speaking about this very important subject.
Yeah, this subject is something of interest to me as well. When I was back in the editorial, I used to cover a lot around transparency and explainability and kind of understand not just from the technical standpoint, but also from the policy standpoint. And there are a lot of things to be explored, especially with the advent of large language models and the explosion around it, with more and more algorithms becoming black box. To start off, a simple question: why Fiddler? What is the name behind? What does Fiddler mean exactly?
Yeah, so I think one of the things that we wanted to build as part of our product was to give humans to interact with AI and develop intuition. And so, basically that's where the whole name came from, Fiddler, because you can fiddle with the models, you can fiddle with the inputs, and ask different questions and see how the model responds with. So, model is sort of like becoming more and more like a complex brain on its own, right?
Yeah.
This is an interaction. You're trying to understand me and I'm trying to understand you. We can both exchange questions. And so same way we wanted to build an interface so that humans can ask questions to AI and basically fiddle with these inputs and see how the model reacts and responds to them. So that's where the name comes from. Yeah.
Fantastic. I thought so. Like, I mean, my guess was that, but I always was very curious about that.
And we are excited, hopefully, one day that people will call they're using Fiddler to fiddle with their AI and building trust with it. Yeah.
Always, it's always about coining the term, right? That's where the media steps in. Hopefully, after this interview. What has your observation been in terms of working? Why did you want to solve this problem statement? What was transparency, explainability done before, and what was that exact problem statement that needed solving, where it inspired to kind of come up with this?
Absolutely. So I've been working on like AI machine learning for about 20 years now. So my first job out of college was in Microsoft Bing as a search quality engineer, exactly 20 years ago, when Microsoft was trying to build a Google competitor search engine. And so one of the strategies that we took up on was, we will actually build state-of-the-art machine learning algorithms to solve the problem of search quality, like being able to give best possible search results. And so at that time, we were implementing neural networks for search ranking. So albeit those neural networks were quite small, 2-layer networks. So from there on, I've been exposed and been working on these type of systems. And what I have seen over the years is AI and machine learning has become more and more complicated. Even back in the day when we were working on 2-layer networks, transparency into how the network was actually coming up with a particular search score, ranking score was not very easy to determine. And so as time progressed, when I was working in companies like Twitter, Pinterest, and Facebook, these systems became very, very complex. You had like deep neural networks, sparse neural networks that would process all the user activity data, lots of Facebook posts and all that, in metadata around it to rank personalized news, personalized ads. And so that's where the question of like, hey, why am I seeing this news story? Why is this particular ad showing up? The question of transparency came in. And so when I was working at Facebook, I worked on tools like Why Am I Seeing This, which basically exposed these human readable insights into how the newsfeed algorithm worked. And that's what got me into the field of explainable AI. And I felt that this was actually something that Facebook could do it, Microsoft could do it, but like not every company had the talent or the skills or the tools to do it. So we wanted to build an enterprise company that could offer observability and explainability as a service to large enterprise companies.
So, what is the current state of explainability? And I would like to understand what that means as
Yeah.
well, in terms of what are some of the parameters that define a good explainable and
Yeah.
transparent model
Yeah.
versus and what is being done
Yeah.
versus when Fiddler steps in, what difference?
Yeah.
is it?
So there are many forms of explainability, right? There is explainability to the developer. Is the developer knowing how the model is working? Where explainability in the sense of, is the model structure simple to explain? Can you actually understand how the model is coming with the conclusion? So a very simple model, let's say you have a decision tree. You can see which pathway of the decision tree actually triggered for a particular model to be, for a particular decision to be arrived. Now, as the model structures become more and more complex, like you have multi-layer networks, deep neural networks, now these large language models, it's very hard to figure out what's going on within the model. So that's one form of explainability. The other form of explainability is to the user who's consuming the outputs of the model. So maybe I'm like I'm working in a bank and I'm working in the underwriting department, and there's a credit underwriting model that's coming up with a score that would determine the credit risk of a particular loan applicant. Or maybe I'm in a customer service department, I'm using a large language model and it's generating a particular piece of content. And so in these cases, as a user, as an operator of these AI systems, I do not know how these systems work, and why is this prediction coming through? What's the response? How is it coming through? And so that's where there's like a little bit of mistrust and lack of transparency exists. And so there, the question is like, I want to be able to develop intuition how the model is coming. So there are these two, types of explainability. The first form of explainability is called the white box explainability, where you're trying to understand the model itself, and it's actually a very, very hard problem to solve for as the models become difficult. The other part is called the black box explainability, where you treat the model as a black box, and you ask these probing questions around the model and try to figure out how the model is doing and try to build trust and transparency with it. So Fiddler takes the second approach, where we basically treat the model as a black box, and we sort of apply these game theoretic algorithms to ask many counterfactual questions. What would the model do if like someone's loan, someone's salary was $10,000? Would they still be approved by the loan credit risk model? Or what if the question was something like this? What would the chatbot generate? So we try to sort of solve this problem of basically treating the model as a black box and asking these counterfactual questions to build trust with it.
Got it. And that age-old question of the trade-off between explainability and accuracy, is that something that? What is your opinion on that?
Yeah, I think it is somewhat true. We have seen that what has happened over the years is that this whole notion of like letting the models learn from data and encoding them into these patterns like the neural networks has been very successful, right? As opposed to like the whole sort of the other form of AI, the symbolic AI, or where you can humans are encoding these rules and you can build these interpretable AI systems. But the complex AI systems have definitely been proven to be more accurate, especially in domains like where you have to classify unstructured data, image classification, or language understanding, sentiment analysis. Now this content generation aspect of it, these large language models, which are mostly opaque, are doing really well, right? And so there is definitely, in certain domains it is true. In certain domains, especially when it comes to structured data, you still have an opportunity to build simpler models that can do actually quite comparably to like more complex models. Say if, for example, if you're trying to predict the readmission rate in a hospital, or you're trying to predict the credit risk score. So there, I think there's still the more simpler models are still effective. You can get a lot out of these things. There is also GAMs and generative additive models that have become successful there. So I think yes, for unstructured data today, very complex models have proven to be very successful, and I think and that's where the world is moving. Yeah.
Got it. Recently, you also did a collaboration and a partnership with Equitable. I think the organization works with a lot of government entities as well. Can you shed light a little bit on
Yeah.
what it is about and how
Yeah.
does that fit into the
Yeah.
objectives of Fiddler?
Yeah, so in Qtel, obviously an investor in Fiddler, they're a partner. They help us work with these government agencies in helping, helping sort of provide tools for explainability and model monitoring. So through InQtel and through other government agencies, what we are working are with sort of defense organizations or intelligence organizations to help them understand how their models work. So one of the use cases that we are working with, like with a very large defense organization, is that they have these they sort of uh, you know are building these computer vision models to detect objects. There could be underwater sea objects, there could be drones, where the computer vision models are detecting, doing these object detection. And so the problem there is, like, when the model actually misclassifies something, why is it misclassifying? In fact, we actually showcase it on one of the blogs, where in this case a model is misclassifying an underwater sea object to be like a plane to be a ship. And so you don't, why is it misclassifying as a ship? So when you actually put Fiddler on it, it basically exposes what are the pixels it actually is looking at to come up with that conclusion, right? And so what it turns out is a lot of the pixels that the model was attributing to were basically coming from the shadow of the image. So if the shadow of the image looks like a ship, and therefore it basically is coming up with this prediction that's like highly likely to be a ship, right? And so when you actually find these situations where this is a classic case where where the model is not looking at the right data, right? Like, so this is where you need to retrain the model. Maybe you don't have enough images with like shadows where you can course correct the model that, hey, this is actually not a ship, this is actually a plane. And so you can retrain it and make it
So internet is improving the accuracy as well.
Exactly, yeah. So by knowing how the model is working, by debugging this thing, by using these explanations, you can then try to identify what are the problematic areas so you can retrain the model better.
Yeah, quite opposite to the question we discussed before.
Absolutely. I think a lot of people misunderstand that explainability is just there's like a trade, like there's like either this or that with explainability and accuracy. Yeah. So even when you're developing these large deep learning models, you actually, explainability can help you detect data leakage, which is a classic case in machine learning, right? One of the use cases that we were working with is in healthcare, where in healthcare what happens is, in radiology, humans actually look at x-rays, and sort of radiologists sort of process that data, right? So now there's an advent of applying computer vision models to classify an x-ray to be, let's say, a cancerous x-ray or a non-cancerous x-ray. Now in this experiment, what was done is, there was a bunch of x-rays where the model was very accurate, and it was classifying to be cancerous and non-cancerous. But then when you looked at a particular set of examples, why the model was classifying, it pointed out to a certain part of the x-ray that is contributing to the cancerous nature of it. What turns out is that particular part of the x-ray had like a couple of tick marks. So this is basically a radiologist marking which were cancerous and which are not cancerous. And this is basically classic data leakage, where the model was picking on signal that it shouldn't be. Just like that shadow signal in the plane example, in this case, we're picking up the tick mark, which is not actually, should not be part of a feature. And so these type of things, explainability helps you catch this. So you can now build a better model, versus like you now found a data leakage issue in your training data set, so you can actually build a better model.
That's a really good example. I think because every time when I have read things, it's always about, especially in the news, it's like there's always a trade-off. So the more complex the algorithm, the more the accuracy is higher, but explainability is lower. But this is a very, very good example of where
absolutely
you are improving the explainability, and because the explainability is making it evident, the model is improving on its accuracy as well. How did your life change after Chat GPT? Because you've been in the space for explainability, and then everything became about generative AI and all of it, and then I'm sure that it's a whole another ball game in terms of that. I'm sure you are doing it in some parts because generative AI existed in some parts of it, but Yeah.
Yeah, so I mean, we were working with language models even before, right? So, for example, we created explainability for like BERT models in the past, which were kind of the early versions of these like language models, and so I think, for example, what has happened with large language models in overall in the industries is democratized access to the AI, right? So, in the past, you had to build a whole bunch of infrastructure, hire a whole bunch of PhDs to get started on AI, right? So now with the pre-trained model being available, you actually can get started. These days what we are seeing is companies, that do not have that much AI talent. They may have software engineers who can pick up stuff by, going through a Coursera course. They're able to get started on large language models, through prompt engineering them, building real applications like, chat bots or search applications. In our case, what we have expanded to is what we call this observability, not just explainability of models, but being able to observe models as a whole, right? And so so there is a whole bunch of things that can go wrong, in the case of large language models. You can have a situation where a large language model could be hallucinating. It could actually leak private data to your users. It could be providing harmful toxic content to your users. And so it's not just about identifying inaccuracies in the model or finding these data leakage issues or ways to improve the model through explanations. It's now about capturing the whole set of exhaust of the models, prompts and responses, and being able to understand the model as a whole and finding out where there might be problematic scenarios. Why is the model hallucinating? Where is it actually is the problem? Where is the harmful comment? Which sort of prompts are making the model basically leak a harmful content or like leak private data. And so that's where we've sort of expanded to. And it's actually a very exciting area, because by solving this, you're solving the problem of AI safety. By actually observing these models, by setting up guardrails around these models, you're now able to help companies deploy trustworthy generative AI apps, which is a big deal, for us as a society, for us as humans, because this thing has to be controlled and reined in, and observability helps you do that.
Yeah, hallucinations is a big aspect where Fiddler will be focusing on,
Yeah,
right?
yeah,
And I think that is one of the major roadblocks that people are facing. While there is a lot of buzz around that all hallucinations are not so bad
yeah,
because
yeah.
they're
It's
essentially being
by design. Yeah,
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 it's by design, and I think that's Fiddler has a really critical role to play in that.
absolutely.
You have also built a platform, Giga Scale Model Performance Management,
Mm-hmm.
right? Can you tell us a little bit about the platform
Yeah,
and what does it do differently in terms of the transparency,
yeah.
achieving AI transparency?
So the thing around model performance management or observability of models is like being able to collect the exhaust of the models coming through. So you have these days people are running models at scale. Let's say if you have one of our banking customers has 1 billion interactions on their chatbot every day, right? And this is not even a large language model. They're still using the old deterministic decision tree based model, right? Now, but there is basically applications being rolled out, whether that's recommendations applications or fraud detection applications, where scale is really high, where you're sending a whole, if you're a fintech company, your credit card company, you have many transactions going through and you're scoring each transaction if it is fraudulent or not. Or you may have like a sort of e-commerce company there where you're serving product recommendations, item recommendations for every user who logs in. So when you have so many interactions, you need like a scalable system that can capture all of these exhaust, which is basically the inputs and the outputs of the models, and process this data and look for abnormalities. Look for things like, are there any data quality errors creeping through? Are you seeing any inputs drifting over time? If you're seeing any distribution shifts happening in the model outputs. So, and then when you see these abnormalities, you can then help the AI teams catch them early and fix them in their production pipelines. Oftentimes, a lot of model performance issues happen because of data errors or data quality issues. So what Fiddler does, it basically collects all of this data and collects the prompts, the responses, the embedding inputs, and helps you alert when things are going wrong and when unexpected things are happening. And that's for that we had to build a scalable platform, that can process millions and billions of these interactions that models are seeing, and provide these visual insights for our customers.
Yeah, and finally, technology is one aspect of it, but from the past 2 3 years, as I've been studying this industry, one thing that I've observed is there needs to be a very strategic approach and a mindset change when it comes to adopting some of these technologies,
Mm-hmm.
right? Especially uh, with Gen AI, everybody is trying to kind of understand, business leaders are trying to understand what are some of the strategic changes in terms of which use cases to take, what is the
Yeah.
right business alignment, what are some of the talent that needs to be approached, what is the governance
Yeah.
model looks like, how does the bureaucracy move
Yeah. Yeah.
around. What is your recommendation to organizations
Yeah.
who are trying to build AI/ML but at the same time
Yeah.
trying to, ethically and
Yeah.
responsibly scale their models in a way that there is good transparency and explainability?
Yep, absolutely. So I think AI and ML is here to stay, right? Especially with generative AI, there is a huge opportunity for every industry to leverage it and use it to optimize your business workflow. We are hearing from travel companies, financial services companies that they're able to unlock tremendous opportunities. Recently, one of the CEOs of a fintech bank called Klarna blogged about how they've deployed an AI assistant that's doing two-thirds of the customer service interactions today, and they are able to see or able to project about $40 million of profit, this year through generative AI, right? So there's enormous opportunities to unlock. Now, how do we do this in a manner that is right? Obviously, it starts with finding the right use case. There are some now sort of well studied use cases for generative AI: customer support, marketing, basically code generation. These obviously are among the top three use cases that we are seeing amongst the customers, especially customer support and marketing, where you have a lot of custom data available. You want to provide support to your customers in a natural, interactive, human understandable manner. You want to provide support for your service agents to do better. In marketing, you want to run personalized campaigns. How do you run personalized advertising campaigns, personalized marketing campaigns based on who's looking at your website, who's looking at your content. So there's a lot of opportunity there to exploit. So to get started, obviously you need a basic sort of generative AI infrastructure tools. So you need like a database that can store all of your custom data in a vectorized format. This is where vector databases are becoming very popular. You need a large language model that can be a third party or an open source model that can basically provide you with these human understandable summarized content. You need like set of tools like an orchestration system that can you can build these applications to federate requests to these large language models, to these databases. This is where tools like langchain have become very popular. And then you need an observability system like Fiddler that can monitor these stack, your application layer, your modeling layer, your data layer, to make sure that your models are performing the right way. So we're calling it like this stack like the mood stack. It's like your model orchestration, observability, and data. It's almost like the lamp stack of like web 1.0, when people were building like these internet applications 20 years ago. So they're almost like you build these tool chain to build these generative AI apps. Now, not only that, then when it comes to responsible AI and sort of trustworthy AI, you need to have some sort of a governance structure. Some of the customers that we work with have this concept of an AI council, which is basically a set of AI leaders and other personas, maybe some people from legal compliance, if it's like a regulatory use case, or product folks, making sure that there's a diverse team that is there that can look at some of these models, how they're being built. There's like an audit log that is being created. There's like a trail of you're capturing all of the metadata, what training data was used to build these models, how the models are coming up with these conclusions, and sort of you can sort of control the whole workflow, right? You have insights into how the models are performing, and when their models are running in production, you have alerts and you have ways to troubleshoot issues, whether they're bias issues or toxicity issues. You can respond to them quickly. So you have a nice process, you have infrastructure, you have the people to sort of do institutionalized responsible AI and trustworthy AI, right? So that's where sort of I would focus on. Pick the right problems, get your infrastructure right, have the right people and sort of processes in place to make sure that you have checks and balances going on, that there's oversight into how your AI is going. And so if you got those three things right, then you're ready to go and build these responsible generative AI apps.
Fantastic. On that note, on a beautiful frameworks note, thank you so much, Krishna, for making the time. I really appreciate it. I think this is a really important topic to discuss. You're doing groundbreaking work, and I'm really glad I got the opportunity to speak with you.
No, thank you so much, Kashyap, and I'm glad that we are speaking about this. Is a very important area, and hopefully we'll keep making progress in this area. And pretty much every team that's out there building AI apps, kind of like comes together and does it in a trustworthy and responsible manner, because we owe it to our next generation that what kind of AI apps that we are building. Yeah.
Spoken like a true environmentalist. Thank you so much.
Thank you so much.